Find the derivatives of the following functions. 7x squared, negative 5x square root of x, and 9 over x to the fifth. So part A. I will show you the long way, and then I'll just tell you the short way. So at first, we would ignore the 7 and just multiply it by the derivative of x squared, which would be bring the 2 down in front, leave the x alone, and take 1 off the exponent. Oh, that should be a 2 there. So what's our new exponent? 1. So this is essentially 7 times 2x, which is 14x. The shortcut would have just said 2 times 7 and then take 1 off the exponent. Okay? So you don't have to break it up, but that's what that rule is saying. So how would you write part B so that we're ready for the power rule? Good. So the derivative, g prime of x, would be what? Negative 5 halves x? So again, multiply the coefficient by the power, and then take 1 off the exponent. So 1 half minus 1 is the negative 1 half. Is that okay? C, how would we rewrite it to get ready for the power rule? Someone else? Okay. And the derivative? Well, gee golly, if only we got to this section before you did your worksheets and your projects. Wah, wah. Last rule for now, for this section, is your sum and difference rule. We have several here. We will do the first one together. We can do them all together. It doesn't really matter. So the first one is f of x is 8x squared plus 9x. Then we have 2 times the quantity x plus 1 squared. And then 5x cubed minus 2x all over x squared. The major rule we know is the power rule. The sum and difference, the constant product, and the constant rule are all just special cases, or not special cases, but they're the accessories to the power rule, if you will. So we have to make sure everything looks like x to a number. The first one is an x to a number for both terms. However, B and C, it's not x to a number. Okay? So B and C are going to cause some problems. But as far as A is concerned, the derivative would say you would just take the derivative of the first part. What is the derivative of 8x? 16x. And then it's got a plus there, so we just copy that down. And what's the derivative of 9x? 9. Because what's your new exponent on x? 0. So x to the 0 is 1, so you're just doing 9 times 1, which is 9. Okay. Part B. Oh, apparently I forgot my alphabet for a second. It happens. So how are we going to make that look like x's to numbers? You have to FOIL. So we'd have to FOIL out the x plus 1 and then distribute the 2 through. So if we FOILed out the x plus 1 and distributed the 2 through, does anyone know what that's going to be? Good. 2x squared plus 4x plus 2. Notice I did not do the derivative yet because what's not here? A prime. So I just did some algebra. Okay. What would the derivative be? x plus 4. And what happened to that last 2? The derivative is 0, because it's a constant. Is that okay? Part psi. Again, we have to rewrite g of x here. How do we do this? To quote a song from the 90s, no, you got to keep them separated. We have to break it up. 5x cubed. Who's that by? I forgot. That's right. Where are they now? Minus 2x over x squared. 90. Really? You know the year? Wow. Okay. 5x cubed over x squared is... Remember, when you would divide two things with the same base, you subtract the exponents. 5x. And 2x, over x squared. Well, write it back as x to a power. Yep. In other words, 1 minus 2. Sure. 3 minus 2. And you divide base. Is that okay? We good? Okay. So the derivative, what is the derivative of 5x? 5. And what is the derivative of negative 2x to the negative 1? Well, the negative 1 and the negative 2 multiply to give you positive 2. And take 1 off the exponent. Very good. So part A is a polynomial. Those are our nicest types of functions. Part B is a factored polynomial. When it's written like that, there is a rule that we will learn at the end of Chapter 12, meaning after we've talked about 10.1. Oh, after we go back to Chapter 10 a little bit. So you don't have to expand it for Part B. Especially, notice I just gave you a square. If I gave you a fourth power, we'll be there for a while expanding. So there's a shortcut. Part C is a fraction. We learn how to differentiate fractions in 12.2, where you don't have to break them up. Because notice, if I gave you more than one term in the denominator, you couldn't break it up that easily. I know. So you're all been warned. Oops. So in this section, we just learned about adding and subtracting. The next section is multiplying and dividing. And that's where those two rules come in. I know.